Today we're going to be checking out an older power station here, this solar generator, this Vigorpool Captain 1200. And I got this a while ago. I haven't had a chance to play around with it yet, but I wanted to check it out and play around with it, do a review, knowing again that this is an older unit and not likely one that you'd be buying new. But I like to do these reviews to kind of overview something that you might find on Craigslist or Facebook Marketplace. And if you find one locally and you want to know, hey, is it any good or not? That's what this review is all about. So if you're looking for up-to-date info on the Captain 1200, stick around, we'll check it out. Hey everybody, it's Chris from FamilyGeekery, and today we're going to be checking out the Vigorpool Captain 1200 portable power station / solar generator. And this thing is brand new in the box, but like I said, it's very unlikely that you'd be buying one new. They do still offer them on their website, but the price on the website is, I guess, the best way to put it, outdated, because nobody would be spending that price on this. Like I said in the intro, you're probably looking at this video if you're finding one of these out in the wild, maybe used, and you want to know, is the thing any good? Now, this does have a unique feature on it that at the time was very unique. Now it's a little bit more common, and that is the parallel function. And by chance, I do have two of these. So I'm going to be popping out two of these. After I review one of them, we'll get out the second one. We'll stick it into parallel mode and test that out as well, just in case you happen to find two of them. They do still sell the parallel cable on their website. We'll talk about that when we get to that section. But enough talk. Let's go ahead and open up this box, pull this thing out, and start looking at the specs, the features, and seeing if it's any good. Alright, so inside the box, and let me mention that this was all very nicely packaged. Not that that's going to matter if you buy one of these things used, but inside the package was a very nice accessory box here that had two cables in it, and the cables were even wrapped in really nice pouches, not just your standard cheap plastic. And we'll go ahead and break those out in a second. And then we got the user's guide, of course, and then the main station itself. So let's grab these cables here, and it comes with a very hefty AC cable here with a nice little branded wrap, and then a car charger, so 12 volt to Anderson plug, and that's going to plug into the front here. We'll look at that in just a second. So you got the two main cables that you need. We don't have a MC4 to Anderson, but that's easy to pick up from Amazon, just $10 or so. And I would like to mention that it does not come with the parallel cable. In case you're looking to parallel these things together, you do have to buy that from the website. At the time of recording, it's $59, but if you find two of these after I test out that parallel function, we'll see if that's worth that extra $59 purchase. Now inside the user guide pouch, we have the user guide itself, and then we got some nifty stickers to put on our stuff, and then a thank you card / warranty registration card. The user's manual is very detailed and has all the specs included, so that's really nice. Hopefully if you get one of these used, someone saved that manual for you, because it does have a lot of information. But let's look at the power station here itself. And we'll look at all the ports first. As far as output ports go, we've got two USB-A's up front here, two USB-C's. We'll test those out. We've got a DC 12-volt plug here underneath the protective rubber grommet, and then two more DC ports here. Those all share 12 volts at 10 amps. All the capacities are written right on here. 18 watts for the USB-A's, 100 watt power delivery for the USB-C's. That's nice. And we'll test to see if that's 100 watts shared, or if we can get 100 watts out of both of those. And we've got a little door here that has our inputs underneath it. So let me lift this up a little bit so you can see. We've got the AC input port here. We've got a little, probably circuit breaker type thing. And then the Anderson input for your solar or your car charger. So let's flip this thing around and see what's on the back side. On the back, we've got four AC outlets here that are 120 volts. They look like 20 amp circuits, but we have a maximum of 1200 watt output from that, with a separate button here for the inverter. And then underneath here is going to be the port to plug in that parallel cable to hook two of these together. Now, in addition to our main inputs and outputs, we also have not one, but two lights. We'll test those out. And then on the top here, we've got a wireless charger. So let's go ahead and turn this thing on and check out the screen. Then let's do a press and hold. And there we go. So we got a very detailed screen here. It looks like we got input and output watts. We got the state of charge along with a little circular indicator and the percentage. And then when it booted up, it had a lot of other information on there that I'm sure we're going to see as we start turning things on. Like now we've got the USB circuit turned on. We've got the DC circuit turned on. And let me turn on the inverter. And that is turned on as well. So we have indicators for all three of those in addition to lights. That's really nice. And then we've got a time here for how long it's going to run. I'm assuming that's going to be both a charge and discharge timer. We'll test that out. But so far, so good. We're at 65%, so I think the first thing we can do is go ahead and plug in the AC cord and test out the AC charging. Alright, so I've got an AC cable plugged in here in the front, and this input port is 120 volts rated at 10.5 amps, but it has an 800 watt max. And 800 watts is fine. A lot of the newer ones, if we're looking at this in 2025, really at the end of 2025 right now, and comparing this up against all the current leaders, your EcoFlow, Bluetti, and all those, they're boasting speeds up to 1800 watts of charging. But you got to really be careful at that point what you plug it into, because if you got anything else on that circuit at home, it's going to probably blow your breaker. So 800 watts, it's going to take over an hour to charge this thing up all the way, and from 67%, it's saying 36 minutes left to charge it all the way up. But still, at 800 watts is fast enough to get this thing topped off quickly without the fear of blowing something up. Now this does have a built-in UPS feature, so while it's plugged in and charging, we can also have something discharging from it, and it's going to completely bypass the batteries and just be in UPS mode. I think it's got a 10 millisecond cutover, which is going to be fine for most electronics and computers and stuff. So if nothing else, this makes for a really nice UPS, being able to handle 1200 watts out of those AC ports. If you lose some power, this thing will keep you going for a while. Now, we haven't talked about the batteries yet, so let's talk about that. These batteries are lithium iron phosphate, which at the time this thing was made, and I think this came out in like 2022, so it's been almost 4 years now. Lithium iron phosphate was kind of new and exciting back then. Now it's kind of the norm, but it is important that it has that, and it's got 1280 watt hours of capacity. So it's basically a 24 volt battery in there, 25.6 volts at 50 amp hours, giving you 1280 watt hours. So that gets us above the normal 1000 watt hour, in a lot of the EcoFlow, Delta series and the Jackery Explorer 1000. Those are all 1000 watt hours or a little over that. So this gives you about 25% more capacity than those, which is why this thing was $1,000 when it came out a couple years ago. So while we've got this thing charging, let's go ahead and test out the solar charging input as well. Alright, to test the solar input, I've got a little power supply here that can put out up to 60 volts, up to 10 amps. That's going to be pretty close to the specs on the port here. And the solar input port is rated from 12 to 56 volts at 12 amps max, or a max input of 400 watts. So I'm going to start here with just 18 volts, and I've got this capped out to, like I said, 10 amps. So we'll see what it can draw at 18 volts, which would be kind of similar to a single solar panel. So let's plug in our Anderson port. And I do have a couple of adapters coming from here to here, and I'm going through one of these guys to give me multiple outputs. So there's going to be some loss in the cables. And we are climbing up 18 volts. We're drawing a little over 8 amps right now. Power supply says it's giving out almost 150 watts. And we've got 130 watts coming in. So not too bad for 18 volts, giving us 130 watts. Like I said, there's going to be some loss. But let's go ahead and crank up this voltage and see maybe if we go from 18 to 36, maybe 2 18 volt panels in series. And now that we've gone up that far, it has drawn a little bit more current, even though I have a 10 amp limit on there. But it is taking that 36 volts and it's drawing 28.93 of it at 11 amps, or 317 coming out of here. We got 283 watts coming in. So let's go ahead and bring this up closer to that 56 volt limit. And I think what we've got here, we've got 48 set on the supply. I think this is trying to draw that full 12 amps that it's capable of, and it's just drawing the voltage down on my supply here. So let me bring this up a little bit more, see if it can be happier with the higher voltage. and it's not. So let me go ahead and unplug this and plug it back in. Maybe if it refines that it's got a higher voltage. And so far that looks to be correct. It's staying at 54 volts. The current is climbing up. And now we have pegged this at 400. So it looks like maybe the solar charge controller just isn't capable of tracking different voltages, which of course wouldn't be a problem if you just had your panels already plugged in, the way that you're expecting them to be, and then plug them into here. But we are drawing 54 volts, a little over 8 amps, and it is pegged out this wattage at 400 watts. And at 400 watts, to top this off from 70, it says 60 minutes. Now let's see if we can combine that with the 800 watt input and get a total of 1200 watts coming in. Alright, so I plugged in the AC cable and it is climbing up, or at least trying to. And yes, it has made it up to 1200. So we got 1200 watts coming in. This is still showing that 454 watts going out, which is coming in here at 400 watts. It is jumping around a little bit, but I wonder if that's just because as we get up higher in the state of charge, it's not going to need as much power coming in. But it seems to be landing kind of at very even numbers. It got up to 1200, it went down to 1100, now it's at 1000. So I wonder if that's just the charging circuit knowing that it doesn't need any more to come in at this point. So let's go ahead and disconnect our solar input here and see if we get this to get all the way back up to 1200. And it's kind of leveled out at 500, not sure why. Let's go ahead and unplug this and we'll plug it back in. And it jumped right up to 800 watts. So maybe it just gets a little confused when it's got multiple things being plugged in at the same time. But it is certainly charging at 800 over the AC. It was charging at 400 over the DC or the solar input. It was only when we combined them that it got a little confused. Alright, so I've got the AC plug unplugged from here. We're going to test the AC output from here, and to do that I've got my trusty EcoFlow Delta 3 over here, because I can easily change the amount that this draws from the wall to charge it up. Now I set this at 600 just to start, and it says that we're pulling 583 watts out, so we're actually gaining about 20 watts. That's magic. I'm just guessing there's a little bit of calibration difference between the two. But basically we are pulling 600 watts out of this battery here into this one. And now I can go ahead and use the handy dandy EcoFlow app here to bring that up. So let's bring that up to 900 watts. And we got some fans kicking off here. And for some reason it didn't climb up much higher. So let's go ahead and turn off the AC circuit back here. Now we killed it out. 0 watts going in, coming out. Let's turn that back on. And I heard some stuff click on. It's supplying some power. And it is not climbing above that 600. So maybe the batteries in this thing just need to be warmed up before it wants to charge any higher than that. So I'm going to let that sit for a little bit, and I'll come back in a second. Alright, quick update. I took the AC inlet cable that was right here, plugged it right into here, so it's coming straight from the wall now, set at 900 watts, and it's still getting 621. So I don't think it's a problem with this at all. Let me give this a second to warm up a little bit, see if I can get that to start climbing above 600. Alright, so it's finally gotten up to 900, and I see the fan indicators on now, so it must have just been a matter of warming this thing up. So let's go ahead and unplug the wall power again. Save that for later, and plug in to the Vigorpool. And wake this guy back up. Let's see what we're pulling now. Alright, so we are climbing up to 900 watts coming in. We got a little over 900 coming out. So far so good. We got a fan coming on over here with a little indicator. That's nice. Definitely got the fan over here. Let's go ahead and bring this up a little bit higher. And I'm asking for the full 1200 now. And we definitely got 1200 coming in here. It's pulling a little over 1200 over here, but it's handling it. Let's bring that down to 1100, just so that we're within the range of what this is supposed to do. And we'll let that sit for a couple minutes and make sure it stays stable. Alright, so this has been working rock steady for several minutes now, way more minutes than what I wanted to test. I was actually downloading the app and going to set up the app for this to test that out. But sadly, it downloaded quick, it found the device quickly, but it could never connect to my Wi-Fi. And I've seen in the App Store several reviews that say that it just doesn't work anymore, and that just may be the case. Now, what I wanted to try next was, I'm going to go ahead and stop this test here. I'm going to plug the charger back into here, get it charging up, and then I'm going to add an 800 watt load from here to see what happens as far as charging at 800 watts and also providing 800 watts externally. Now, I think it should work in that UPS mode, but we're going to test that out. So I'm going to bring this down to 800 watts first. And there we go. So let's go ahead and turn off the inverter over here. And we are all back to 0. Let's get this guy charging back up again. And we are charging at 800. Now the reason why I wanted to test out the app is so I don't have to reach around here and turn on the inverter. I could have just done it from the app. But let's go ahead and turn that inverter back on, remembering that I still have this 800 watt load ready to go over here. Alright, so at first glance it looks like we've got 800 watts coming in here. That matches the 800 going out of the inverter. And it's showing 500 watts coming in charging. So that leads me to believe that there's about 1300 watts coming in this cable here, and it's charging 500 of it to the batteries, and it's sending 800 straight out to the external device. So if that's the case, let's go ahead and lower this down to like 500 watts. And there we go, and sure enough, now we've got 800 coming into the batteries, 500 going out to the external device. So just to verify that, I'm going to go ahead and put a watt meter in line with this input here, just to double check. Alright, so a couple fancy adapters later, here is a power meter showing 1363 watts coming out of the wall, going into here, which is being split up to the batteries in this case, now with a full 800 going to the batteries, and a 500 watt external load. So now, last thing to do to test this whole setup is I'm going to kill the power from the wall and see if this still gets its 500 watts pretty much instantly. So let's go ahead and simulate a power outage here. Now this is dead. And it did take a quick second, but it pulled right back up to that 500 watts. Alright, so I'm happy with the AC test, both the charging and the discharging. Let's go and test out these USB-C ports here, because I think that's the next thing that we should take a look at. Alright, so to test the output of these USB-C circuits here, I've got an Anker Solix C300 DC over here, which is capable of taking 140 watts into these ports. And you can see I've got 60 watts going out, about 60 watts coming in. I know that's really small, but that's what it says. And that's because I've just got this regular old USB-C to C cable, and it's just rated for 60 watts, I imagine. So unless it has a label on it, or you know for sure that it is rated for up to 100 watts, don't be surprised if it's not. Now in this case, this one actually says 100 watts, so I'll believe that. So let's plug that into here, plug it back into the USB-C output, and now for sure we've got 99 watts coming out of here, 96 coming in, so that is good to go. Now what I want to do is plug a second cable in, because this same device can handle more than 100 watts in. I think it can handle 200 and something. So let's go ahead and plug in another cable, and this one is rated at 140 watts. I'll plug it into the second input here. Now it's going to lose its mind for a second as it renegotiates, but it is climbing back up, and there we go, 198 watts. Got 192 coming in here. So yeah, sometimes these are shared, sometimes at 100 watts, if it says that, it is shared between the two, but it looks for sure like this is handling 200 watts output, so you can have 200 watt devices plugged into these, whether they're laptops or gaming machines or whatever it is that you want to plug into those. It looks like it can certainly handle that. Alright, and the last test I want to do to this unit here before we go ahead and grab the second one and do that parallel test is I'm going to test out the 12 volt output here. So I just got a cigarette lighter to XT60. I can plug that right into here. And let's turn that on again. And this is capable, I think, of 100 watts of solar, and that's basically what this is simulating here. And we've got 103 watts coming out, 97 watts coming in, so it looks like that's good to go. So let me go ahead and grab the second Vigorpool and get the parallel cable. We're going to set that up, and we're just going to test that out real quick. Alright, so here are my two Vigorpool Captain 1200s, and here is the parallel cable. Now again, I got this straight from the Vigorpool website, and it was $59 as of the time of this recording. So we're going to see if that's worth it in this video. Now, let me go ahead and hook this up into the back, and I'll be right back. Alright, so I've got the two stations turned on. I've got the parallel cable plugged into the back. The parallel cable is dummy proof. It only fits in one way, and it has a spring-loaded connector that makes it super easy to connect and disconnect. So they're both connected together. I was hoping to see some kind of an icon on the screen here that showed that, but I don't see it. But it's my understanding that that parallel cable only connects the two inverters together and doesn't connect everything together. So if you want to charge these stations, you'd have to plug a charger into this one to charge up this one. You'd have to plug a charger into this one to charge up that one. So the charging circuit isn't paralleled. And then same thing with solar. And that's a good thing and a bad thing. At least you can have 400 watts of solar going into both of these. So you could have solar input charging at both stations at the same time with two different strings. So really what you're doing is you're just doubling the capacity of the inverter, which is normally 1200 watts, which is, albeit a little dated for today's technology, but it still does, the majority of what people need to do with these portable power stations. So we should be able to get 2400 watts coming out of the inverter by using both of them, and it should draw from both batteries. Now it won't charge both batteries when you're charging, but it should draw from both when you're using the two inverters. So what I've got this EcoFlow, which is just off screen here, the same one we were using before, plugged into this inverter. I don't have it turned on yet, and this is just parallel. Nothing is plugged into it, input or output, other than that parallel cable. So let me turn on this inverter, and we'll start playing around with the charge speed of the EcoFlow. Alright, so right now I've got it turned on. I still have it set at 500 watts, and it's pulling 500 watts from this unit only. And I've got this little icon here, which I believe means parallel. So once I did turn on the inverter, that icon showed up also. And I'm getting 500 watts into this station, no problem. Let me shift things around a little bit. Alright, so now we can see the 500 watts coming in, 500 watts going out. Nothing's happening over here. So let's go ahead and take this app here and ask for some more. Let's bring it up to that full 1200 watts now. Alright, so we got some fans going now. We got 1200 watts coming in here, 1200 watts coming out of here, and nothing here. So maybe the inverter needs to be turned on. So let me go turn that on. Alright, so that was the ticket. As soon as I turned that on, now the load is being shared between the two. 662 watts coming out here, 550 coming out of here, and we got the full 1200 coming into here. Now I'm going to crank it up all the way to 1500 watts, which is above the limit of any one of these by itself. And we're getting into a situation again where I don't think this is asking for the full 1500 right now. And it may be because it's getting pretty full in capacity. Alright, so I couldn't get this to pull any more than that 1224 there. So I brought in a little portable space heater. And I'll go ahead and turn that on, which should pull around another 400 to 500 watts from, again, this one, which is going to be hopefully shared between the two. So I'm going to go ahead and turn that on. So there we go. Now we've got almost 1800 watts combined between the two here coming out. And it's all coming out of this station right here. Obviously using both of the batteries. I've got 1200 coming to here and another 500 or so coming out of this heater. So that parallel cable works great. And I'm curious if it's simply the fact that the state of charge of this one is higher than this one, that it's drawing more from here than from there. So I'm going to do one more bonus test for you. I'm going to go ahead and shut everything down, get this one charging, get it above the state of charge of this one, and see if those two reverse. So give me a minute to set that up and I'll be right back. Alright, so I've got this one charged up here about 10% higher than the original one, and it looks like it is not using that as a determination of how to split that load. It looks like it still favors the one that it's plugged into a little bit, and maybe that's because it's directly coming from here and we're losing a little bit maybe it thinks it's sharing the load, but it's losing a little bit over that connection cable. But I'm not sure. It would have been kind of neat if it was smart enough to know which one had a higher state of charge, and it scaled the load depending on that, because we can see here that this one says it's going to run out in 30 minutes, whereas this one is going to last for 44 minutes. So if you are using this in that parallel capacity, then you will want to kind of keep an eye on the state of charge on both of them as they both time out for me, and make sure that you don't run one of them dry before the other one is still going and trying to handle the whole load. But certainly a nifty feature nonetheless, being able to pull 2400 watts out of the combination of the two if you had something that was a very high load that you wanted to power up, as opposed to, you know, two smaller loads that you could obviously plug into them individually without that link cable. But if you did have something, table saw or something that you needed a lot of power from, then this situation would definitely work. So let me clean some of this up and come back with some final thoughts. Alright, so now I'd like to go ahead and kind of summarize some of my final thoughts on this Vigorpool Captain 1200 portable power station / solar generator. And remember, these thoughts are coming from the standpoint of it is now 2025 or after. This thing was developed and produced and debuted well over 3 years ago. And how does it sit in today's market? Well, obviously, when you compare it up against like the EcoFlow Delta 3 Plus that I had over here for part of the test, it's going to pale in comparison to some of the features, the app functionality, the maximum output of the inverter, the solar charging capabilities. It's going to obviously not measure up to those standards that we have today. So what I pay, if I found one of these used, would I pay the same thing for it that I would pay for a modern 1000 watt hour power station? Maybe the Jackery Explorer 1000, the Delta 2 or Delta 3, or the Anchor C1000. No, I don't think so. Even though it does have 280 or 25% more battery than those, I think the money would be better spent on the other ones. So obviously, if you find one of these in the wild, you would want to spend less than whatever the going rate for those models are. Now, would I spend the same on this as I would on one of the medium size, like 600-700 watt hour units, like the River 2 Pro, or anything really with the 600 or 700 in the name? Then I think yeah, because most of those have like a 1200 watt inverter. Most of those have 600 to 800 watt hours of battery. So this is going to match or be better than those. Yeah, the modern ones are going to have a better app, but I think even by itself, doubling the size of the battery is going to be worth it money-wise. Now, if you are lucky enough to get into a situation where you find two of these in the wild, and you find the cable with it, then that certainly changes the perspective of what the value of these things are. If you find two of them with the cable, then that is obviously like a 2500 watt hour power station with 2400 watt inverter. Now it's going to stack up against some much more expensive, at the current time, I would say $700 or $800 units. Now, can you get something today that's just a little bit bigger than this single unit that has the functionality of both of these units? Yeah, they're packing a lot into a small package these days, so obviously keep that in mind. But the bottom line is, I'm pretty impressed with what this thing did coming out of the box, probably for the first time since it was made 3 years ago and put to the test, and everything worked. Now, I totally forgot to test out these lights, so as I'm staring at it right now, let's go ahead and push the button a couple times and see what happens. Now remember, there's one on each side of these things, so let's turn this thing back on. Push the light button once, and it's a decent LED array here. Push it again, it gets considerably brighter. Push it again, and there we go into blinky blinky mode. And once again, looks like an SOS mode. And then back off. And those are independent. Having that one on doesn't turn this one on. But that is kind of a neat feature to have one on each side, because now if you put this in the middle of a room or a tent or something, you're not just lighting up one area, you can light up basically a whole area. So all that to say, yes, I'm pretty impressed with the Vigorpool Captain 1200. Yes, it is a little dated in today's features and standards, but if you find one and you have any questions about it, go ahead and drop those down in the comments below. I'll be happy to answer them. Hopefully this video was helpful to you. Hopefully it educated you in some manner. If it did, I appreciate a thumbs up. To help out with the old algorithms, go ahead and drop down a question or even just an emoji down in the comments below. Go ahead and check out the rest of the channel, see what I got going on there. Lots of other tests on power stations, portable power banks, solar stuff, and basically everything else geeky. But that's going to wrap it up for this one. I thank you as always for watching, and until next time, peace out and geek out.